Simplified on Bharata first. Through this show, we provide the platform to let your curiosity out and ask questions related to science and technology, which will be answered by our experts. To send us your questions, you can submit through a form whose link has been provided in the description box below. Do make use of this opportunity. Now, I would like to introduce to our science expert, Dr. Tv Venkateshwaran, who is here with us to answer the question which is sent to us by our viewers last week. Dr. Tv Venkateshwaran is Senior Scientist of Vigyan Prasar, New Delhi. He is also the founder editor of India Science Wire. His area of research includes science, technology, and society. And he also writes regular columns on the developments related to science and technology. So, the first question for today is:
Hi, my name is Abhinay. I'm a UPSC aspirant. My question is regarding quantum computing. Recently, Google has built Sycamore, a quantum supercomputer, which is supposed to be thousands of times faster than the fastest supercomputer on Earth. I want to know, how does a quantum supercomputer work? What makes it so much faster? And what potential applications does it hold? Apart from this, in this race of development of quantum supercomputer, where does India currently stand, and what more can we do to be ahead in this race? Thank you.
Thank you. I mean, it was a really very interesting and wonderful question. Uh, Quantum computing actually uses some of the fundamental ideas of quantum mechanics. Like in a classical computing, we use a switch, which can be either in an on position or in an off position. Or you can look at it like a small point, which is either charged or not charged. I mean, you can look at it in any of these ways. We usually say that it is either in a 0 or 1 binary, right? So you have only two possibilities. So we call that as a bit. But whereas in quantum bit or qubit, you are using some of the interesting potentials of quantum mechanics, so that at the same time you can get a large number of possibilities, not just 0, 1, but many. This would mean that you would be able to use more data points to represent something or work on it. Let's look at, like, say, for example, if you have only 0 or 1, okay, 0, 1, 1 gives you only one option. But whereas when you can represent it in multiple ways, it can give you multiple options. Okay. So usually, typically, for example, we use 8 bytes to represent a number. Okay, a floating point. So if you are looking at a complex number, which is like x plus iy, if you recall a bit of your school mathematics, then you would require something like about 16 bytes. Okay. So, but whereas yeah, n qubit, okay, so it will be like 16 into 2 to the power of n. Okay, so it is 2 to the power of n plus 4 bytes. So, yeah, ordinary computer which just gives you a 8 GB. Now you can do it with just 29 qubits. Okay, yeah, ordinary computer which has a memory equivalent of 8 GB, you can just do it in 29 qubits. So you can see that how much with a small memory you can store a large number of information. Essentially, in quantum computing, we are harnessing what is called as superposition, meaning that in quantum mechanics, as we know, the principle of uncertainty, it's neither here nor there, right? So it is neither 1 nor 0. It is that superposition, multiple superpositions are possible that you can yes, harness. Second, a very interesting property called as entanglement, which of course we are not very clear. Only future science will make it more clear. Which essentially means that if we have a pair, which are entangled, changing one will change the other. Okay, so this the changing state of one qubit will instantaneously change the state of other in a very predictable way. This quantum entanglement that you can do. But one of the major challenge in quantum computing is decoherence, meaning that if there is even the slightest disturbance of the environment, maybe there is a change in temperature or things of that kind, the quantum state will decay, right? So it's something like, for example, if you apply intense electromagnetic wave on your computer, your memory will be completely erased. Okay. Uh, in the same way, for example, quantum mechanics can go on. So you need to keep quantum computing in a super cooled environment. So that's a kind of principle that people are working on. One can't say that right now you have a very working some quantum computer which are actually used in application. People are building, let's say, ideas, model, challenges in quantum computing. So if you look at it, for example, the first demonstration by IBM happened somewhere around 2015. Okay, so till now, most of the quantum computing that is happening is essentially demonstrations. The breakthrough is, for example, this Chinese mission, which, for example, is having a capacity which is 10 billion times faster than the 53 qubit quantum computer developed by Google. This has close to about 76 qubit, just 76 qubit, but the computing power is, I mean, it can work very, very fast. Okay, very, very swift. So, what is it useful for? I mean, if you are going to use it for simulation, weather prediction, where large number of parameters you'll have to take into account, and they are constantly changing every second, right? So, if you want to model it, then this kind of a quantum computing is going to be the future. And India has taken steps. For example, in the Union Budget 2020, a mission has been announced for quantum computing, and about 8,000 crores have been allocated for next few years. Under this mission, number of institutions will be brought in. The principle will be used for engineering solution for complex problems like communication, sensing, chemistry, cryptography, imaging, and many areas. Okay. Broadly in India, we are hoping that this high level committee which has been formed, a mission which has been formed, would focus on four domains of quantum technology: quantum communication, quantum simulation, quantum computation, and quantum sensing and metrology. And with VK Saraswat as a chairman, Apex committee has been formed. We will be working on this area in near future.
Hello, I am Prateek and I want to ask how does the Iron Dome defense system of Israel work? Thank you.
Iron Dome is a metaphor. Okay, dome, is like a cover. Iron is something very strong. So it is a missile system which is supposed to give protection to Israel. Okay, particularly by attacks, missile attacks from enemy territory. Basically, it works like this. Okay, I mean, there are currently about 10 batteries which have been deployed around Israel. Five more they are hoping to deploy. Each of this launch platform has 3 to 4 launchers. Okay, carrying about 20 interceptors. Okay. Each of this battery cost about 50 million US dollars, and per missile is 40,000 US dollars. So it's not a simple solution; it's a very costly solution. What does it do? If, for example, there is a enemy rocket coming from enemy territory, missile coming from enemy territory, when it crosses the border, the system senses and send interceptors, which go and destroy the enemy missile. That's the essential action that takes place. So basically, that's how the radar system detects the enemy missile. Then the battle management system sends out communication. They are all automated. Okay, it calculates the threat potential, the trajectory of the enemy missile, and so on, and then sends information to the interceptors. The right interceptor, whichever is the one which will be able to target that missile, is immediately activated, and the missile can go at the speed of 2000 kilometer per hour. So, which means that with a short time, I mean, it will be able to react and then neutralize the enemy missile. That's essentially the Iron Dome that Israel has deployed to defend itself from the enemy territories around it, its borders.
Hi, my name is Swan, and I'm from northeast of India, Manipur. I've done my BSc in physics, and I'm a civil service aspirant. My question for this week's Science Simplified is: what is CRISPR technology? How does it work for genome editing? And what makes it a breakthrough invention? And what are the potential side effects and the ethical issues involved with it? Thank you.
CRISPR is the latest, most modern biotechnology tool that we have to make gene editing possible. We have all worked with, for example, a Word document, right? I mean, we all use computer to create a Word document. Well, after some time, you may think that you want to edit it. Okay, you have used a particular word. Maybe you think that you have used the word multiple times. Maybe you spell that word wrongly, and you want to correct it. Okay, so what do? How do you search? You go to the find and replace. You enter the word that the wrong spelling that you have done, and then the correct spelling as replace, and then put a entry. The software automatically takes to each point in your document where that error is present. Okay, whatever that you wanted to find is present, right? It takes you to that point. In a way, for example, the CRISPR editing works like that. So if you look at, for example, a genome, okay, I mean, this genome can be of human genome or a bacteria or a plant. Okay, so there is a genome. In the genome, there is a particular place where you want to make a editing. So you know that in the genome, that the genomic order. Okay, so you create a protein called as Cas9 protein, which is basically a CRISPR tool. Okay, that CRISPR tool will have a particularly custom designed sequence, which will then this take this protein to the target in the DNA. Once this target is identified, at that position, the Cas9 makes a cut. The DNA is cut into two pieces. Now you can do multiple things. You can remove some genome information and then make the remaining genome heal itself, or you can insert a new genome. So basically, CRISPR is a acronym for clustered, regularly interspaced palindromic repeats. Okay, it's a gene editing technology. In fact, the bacteria use this to fight against virus. In fact, we learned it from bacteria. When we studied bacteria, we learned this technology. So basically, what you can do is that once you do the CRISPR editing, you can do deletion and allow the remaining part to heal, or you can cut a DNA and insert a part of a donor DNA, and then you can create a new DNA with a new genetic information. Okay, so this is what you can do. So it's basically like you are editing a document, you are changing words in between or sentences in between. Okay, genome is like a program for a computer. It has commands, right? So it tells our cells to produce particular protein. If it is a plant genome, then it tells the plant to produce a particular protein to express certain phenomena, right? So using this, you can create wonderful changes in the way, for example, we create new seeds or new plants, for example. Okay, you can have, for example, virus resistance. You can take the viral resistant gene from some other species, insert into the plant that you want to have that particular viral resistance. Okay, so you can create that kind of a plant. You can create a plant with the disease resistance, basically a plant which will secrete certain chemicals which will attack the pest or fungi that it is which is attacking the plant. You can also change the physical and chemical resistance, like you can make crop resistant against drought. Okay, you can improve the crop value. That is, you can increase the nutrition value by making the plant produce seeds with, let's say, more vitamin A. Okay, or iron rich seeds. I mean, you can get out of it. So basically, for example, iron rich wheat you can produce so that anemia can be, for example, addressed. You can also manipulate and get bioactive compounds. We are collecting lots of bioactive compounds for drugs and let's say, for example, even for flavor and things like that. So you can manipulate and create bioactive compounds. So these are all some possibilities with CRISPR where people are working on. With respect to, for example, human disease management, there are a lot of work happening. So let's say, for example, if you're looking at cancer, cancer essentially happens because there are some oncogenes in our genes. Okay, a certain part of our genetic information actually promotes cancer to happen in our body. So can we edit it? Meaning that can you remove it? You can knock out or you can inactivate it. Okay, so these are all some possibilities that you have with the CRISPR. Then you can repair tumor suppressing genes. Okay, so to ensure that the tumors don't happen. So there are also genes which actually make us drug resistant. Okay, so we need to be given a huge amount of drug. The dosage has to be high for it to have any effect. So if you can modulate the genes which is promoting the drug resistance, we can enhance the drug sensitivity. So even a small dose will work. Okay, so you can also tinker with, for example, the immune system, T cell, and then restore immunity so that the cancer can be fought by our body with this kind of a gene therapy. These are all some areas in which research work is going on. Actual therapy has not come in, but people are working on it to find out whether this CRISPR can actually help you in that. Some animal studies have taken. For example, here you see two pigs. Okay, the first image is at the 0 hour, and second is at after 2 hours, and the third is after 4 hours. When both these pigs or piglets are exposed to extreme cold. Okay, when we are exposed to extreme cold, our body starts producing temperature. I mean heat, right? We generate. I mean, we use energy to generate heat so that we are able to maintain our core temperature. That the cold does not damage us, right? So that's what we hope to achieve, right? Here, for example, the first pig is an ordinary pig. The second one is genetically modified. That is where you have had a CRISPR technology to do a gene editing. Okay, so when you expose, you can very clearly see that the pig which is gene edited is able to withstand the cold. Okay, it is able to produce enough body heat to withstand the cold. So these are all some laboratory work that is happening today. These are all laboratory works, but when you talk about the human, there are lots of ethical issues that comes before us. Okay, uh, not many countries have approved, for example, tinkering with human embryo. Although in Europe and US, the drug controllers have permitted clinical trials to edit human DNA with respect to some of the diseases like cancer. Okay. Some research work like this is happening in some of these countries where people are trying to find whether the CRISPR technology can actually aid us in addressing some of these diseases. When you look at the ethical challenge, can you, for example, modify the embryo and get what popularly called as designer babies? That is, you go and tell your doctor that I want a baby with, let's say, blue color eye with the long eyebrows, etc., etc. And then gene editing is done, and then the embryo is put into you, and then you give birth to that baby. Is it really nice to do such things? Okay, so these are all issues which are related to axiology and ethics, where human society has to come to terms with it. Okay, then there are also people who are talking about bringing back extinct animals, animals which have become extinct. Can you use gene editing to bring them back? This is also again an ethical challenge. Is it really right to do such a thing? Okay, if you do gene editing in cells which are like called germline cells, like the sperm or egg, then the gene editing will be carried out over throughout generations. So you are not only editing for you, but you are editing for the whole future generation. So can you make that kind of a tinkering for the whole future? That's also a big challenge, ethical challenge that will be for us. Last one, our world is unequal. Not all people have access to resources. Not all geographical locations have access to resources. So if people with the money is able to produce babies who will be, protected against cancer or many of these diseases, but not another section of human population, would that not create a very fundamentally unequal society? uh, at least in democracy, we start with this presumption that all people are equal, right? But then by design, if you apply this CRISPR editing unequally, uh, then perhaps all people are equal, maybe only in paper, not in practice, not ever. That kind of a big challenge is before CRISPR technology. So these are all some of the ethical issues that the scientists and professionals are engaged with.
Hello everyone, I am Khushi Jain. I am from Shamli, Uttar Pradesh. I am a science student studying in class 12. Today, I feel privileged to be a part of Science Simplified. My question is, recently NASA has confirmed that Osiris-Rex is on its way back to Earth. How significant it will be to understand the origin and development of solar system and Earth. Thank you.
This NASA mission, which is bringing back a sample from an asteroid, it will be a milestone in space history for time to come. Okay, there are multiple reasons why it is so. So, Osiris is actually a acronym for origins, spectral interpretation, resource identification, security, regolith, explorer. That's the sense that it has. Okay, the mission was launched in 2016, and then the sample is supposed to return to Earth in 2023. It's on the way. Okay, So it goes to a asteroid called Bennu, okay, and then it studies that asteroids and then collects some sample and then bringing it back. So if you look at that asteroid is comparable to the size of Empire State Building or Eiffel Tower. Roughly, that's the size. That huge rock that is going around the sun. Okay. What did it do? I mean, it went very near to Bennu. Okay, and then it did what is called as a touch and go maneuver, meaning that it went very near to the surface. It blew puff of nitrogen gas. So the dust from the venue came up and the dust was collected, and then that sealed container is going to come back to Earth. So what does it will tell us? Number one, we will be able to find out composition of this asteroid. There are talks that in future for resources that is needed on Earth, like iron, nickel, lithium, and many other material. Instead of mining the Earth and creating environmental havoc, people are talking about why don't we mine asteroids and bring back only the useful material to Earth. Okay, so if you are to mine asteroids, then you need to know what is there, right? So this is the first step toward understanding such resource availability in asteroids. That's one. Second, if you look at, for example, a housing complex which is constructed, okay, and if you go to that housing complex, almost immediately after the construction is over, what you would find is that there'll be a brick, half a brick lying somewhere, a paint box lying somewhere, okay, a brush lying somewhere. Basically things which were used to construct that building. So if you collect this material, you can know what has gone into the construction of the building, right? In the same way, asteroids and space rocks which are going around the sun are material which are remaining from the beginning of solar system. Okay, in the beginning there was a huge gas cloud and small rocks and so on, and slowly the sun formed, planet formed. So these are all the remains. So if you study the remains, you can know about what was there in the past and how actually the solar system evolved. So you get an answer to a science question, how the solar system evolved, and also a practical question: can you mine asteroids? This is the importance of this mission.
Namaste, I am Bhavil Mishra, final year student at Maharaj Sayajira University, Vadodara. First of all, I would like to thank Bharata first to letting me ask question in Science Simplified. My question is, increasing use of plastic in various products is a cause of concern in present times. What impact does microplastic causes to the human life and other lives also? Thank you.
Basically, any plastic material which is less than 5 millimeter is classified as microplastic. Okay, and broadly we classify microplastic as primary and secondary. What is primary? It may be materials like, for example, the fiber from your cloth, okay, or some cleaning liquid that we are using, which may have plastic material, right? So basically, the material that we use might get leached and then would be polluting either the land or sea or water bodies. Okay, so that's a primary source. Then there is a secondary source. Secondary source is that when some bulk material degrades. Let's say, for example, you throw a plastic bag in a landfill. Slowly, the plastic bag will degrade in a sense that it will break up into smaller and smaller parts. Okay, so then it can become a microplastic. Maybe a water bottle plastic bottle was thrown in a sea, or your sewage water takes it and puts it in ocean. Okay, so there the plastic bottle can degrade and become microplastic. Recently, people have done a survey of ocean. Okay, though they collected microplastic from ocean and they classified it into what is the source. How did this microplastic came in, right? So what we know is like this chart over here, cellulose, which is a plant product, or cotton, all these are cellulose, wool, bone. These form some important aspect of microplastics. Then rayon, polyester, basically the artificial fibers that we use. Then acrylic polyester, which we use to make pipes, bottles, and so on. These are also some of the important contributors. So there are other synthetic, and also there are other natural source for the microplastic, and there are some microplastic we don't know what exactly is the origin. Okay, what is the thread of microplastics? If the microplastic is ubiquitous in, let's say, for example, an environment like the ocean, okay, then a process called as bioaccumulation. What is this bioaccumulation? For example, there may be small sea organisms which may eat this microplastic. Okay, of course, they won't be able to digest, so it will be inside their body. But then this small organism could be eaten by, let's say, for example, a bigger organism. But the bigger organism will not eat only one small organism, but multiple small organisms. Okay, so when they eat, all these microplastics accumulate in the bigger organism. So then there is a chain, right? So finally, the fish which is caught in the sea, which comes to our table, might contain a huge amount of microplastics, which perhaps when you eat, it may get into your system, it may stay there, or through your fecus again go back into the environment, or in rare cases, it may come through breast milk. Okay, and it can cause both environmental problem and also health issues for human beings. That's the worry that people are talking about, and that's why the area of microplastics has become a hot area of research today. We don't know. As I showed you in the chart, there are also natural sources for bioplastics and also synthetic sources. Okay, and how this has changed over a period of time, and how big a problem it is. These are all questions that scientific community is currently engaged with.
Thank you, sir, for your insightful explanation of the questions. Please like, share, and subscribe to Bharata First for such amazing content. See you again.